the Grand Canyon Skywalk, a man-made engineering wonder hanging over one of the world's great natural wonders, allowing visitors to see the Grand Canyon a completely different way.
Beautiful. It's frightening. It's beautiful.
Oh my gosh, that is so scary.
Look at that.
No.
Awesome.
How will engineers build this amazing bridge 1,200 meters above the Colorado River? For the first time on television, the extraordinary story of the Grand Canyon Skywalk, wonder of the new millennium. "1,200 meters above the Colorado River, the Grand Canyon Skywalk appears to float on air. But don't be fooled. It weighs in at nearly 500,000 kilograms of steel and 29,000 kilograms of glass.
Wow.
This walkway is heavy-duty, built to withstand the forces of nature that created the natural wonder below. It took almost 4 years and more than $30 million to become a reality, and it doesn't disappoint.
3, 4, 5. I got it.
It's breathtaking, it's unbelievable, it's just a crystal view. I think when you see eagles and other birds flying 1,000 feet below you, it's really awesome.
This spectacular human achievement combines state-of-the-art engineering and ancient technology to showcase the eternal beauty of the Grand Canyon. But its simplicity of form is deceptive. As a major engineering project, many obstacles challenged the creators of Skywalk. A beautiful but barren location, ancient geology, tribal controversy and environmental restrictions, ripping wind, and the fear of building a glass bridge over an enormous cliff just off the imposing west rim of the Grand Canyon. The Skywalk is located almost 200 kilometers east of Las Vegas, in one of the most desolate areas of the United States. A harsh climate contributes to the isolation. Temperatures range from 46 degrees Celsius in the summer to -2 degrees Celsius in the winter. Winds over 160 kilometers per hour have been measured, blowing through the canyon. This forbidding landscape is home to the Wallapai Nation. For decades, the Wallapai have opened their reservation to tourism to help support the tribe. But their main commercial enterprise, river rafting, is modest. In 1996, entrepreneur and developer David Jin approaches the Wallapai with a bold idea. He's a tour operator who's been bringing tourists to Wallapai sites for years. He proposes building something new to draw more visitors, a glass-bottomed walkway or observation deck, jutting out over the west rim of the Grand Canyon, complete with a visitor center.
I've been doing business with the Wallapai tribe for a long time, over 10 years, and I love this location. First is very close to Las Vegas. Second is they keep the Grand Canyon, just like, a few million years ago.
For the Wallapai, who own the land, Jin's proposal and the scale of tourism it would draw challenges a delicate balance between commercialization and preservation of nature. Within tribal families like the Watanabe's, opinion is sharply divided. should they build Skywalk?
I said, well, we need to have income. We have to look at the needs of the people. So we had to change our ways.
In the beginning, I opposed the project because I grew up with this being a naturally beautiful place. And I thought that, building the Skywalk where it is today, we infringed on the spirituality of the place.
On one hand, it's going to bring employment, help with the poverty situation. But on the other hand, perhaps desecrating the canyon in its natural state. So, it's mixed emotions.
After years of internal debate, the Hualapai approved Jin's proposal, with specific restrictions. No underground rooms or excessive excavation. No drilling into the face of the canyon wall. And color and texture of the structure must complement the natural environment of the canyon.
Aesthetically, we wanted the coloring, we wanted the formation to blend in with Mother Nature to the extent possible.
In October 2003, Jin hires architect Mark Johnson. While Johnson has years of experience in commercial and residential work, he recognizes the challenge. No one has ever designed anything like the Skywalk.
I was kind of asked to help David Jin kind of create something, some sort of an experience that kind of captured the feeling that he had of the first time he was at the canyon when he watched the eagles soar through the canyon, almost effortlessly just floating through the canyon.
To tackle this challenge, Johnson and Jin take their plans to Locksaw Engineering, the masterminds behind many recognizable hotels in Las Vegas, including the Wynn Resort, Mandalay Bay, and Caesars Forum Shops. Locksaw also has experience building with glass, having designed the Shark Reef at Mandalay Bay. At Locksaw, Jin and Johnson meet engineer Bill Karen.
We finally got together and said, hey, do you think we could maybe shove this thing out 50, 60, 70 feet and not attach anything and have a big opening in the middle so you could feel like you were flying almost?
Karen is intrigued.
The first thinking was, this is pretty wild. It'll be fun to do, different, and it did have a big coolness factor.
While Johnson and Karen pore over blueprints, developer Jin and the Hualapai pick out a location, a stunning site on the west rim called Eagle Point, because it looks across the canyon at a distinctive rock formation in the shape of an eagle. The spot is sacred to the Hualapai because they believe the eagle lifts the prayers of the people to the Creator. Unlike the stair-step formations found in much of the canyon, here the rock walls drop precipitously for the first 600 meters. In addition to the sheer rock face, the site offers a tremendous view of the Grand Canyon and Colorado River. The team hires geologist John Peck next to inspect the proposed location.
I went out in November and spent a day mapping the surface geology at Eagle Point. And the location was right adjacent to a major crack, an open fracture in the rock. I'm amazed that that has not fallen yet, that wedge of rock.
Peck immediately determines that the site is not suitable for the Skywalk. But he spots a better location just 100 meters to the north. Here he also finds fractures in the rock, but with a significant difference. The cracks, also called joints, are angling away from the canyon, not toward it.
The joint surface is pitching toward the canyon, and you load that, it has a tendency to slip down toward the canyon, initiating what would be a rock slide. If they're tipped back away from the face, that's a much more stable situation.
Engineer Bill Karen now begins research for Skywalk's foundation. First, he tests the compressive strength of the rock. This is done by placing a sample of the rock in a vice-like machine that literally squeezes the rock until it is crushed. The The red limestone at the site withstands an astounding 1,125 kilograms per square centimeter of compressive pressure.
16,000 psi bedrock would be comparable to 4 or 5 times the strength of the average person's driveway or the concrete sidewalk in front of your home.
Knowing the high compressive strength of the red limestone rock tells Bill Caron that drilling will be difficult, but not impossible. Now he focuses on the next challenge, how to marshal the manpower, equipment, and resources to begin construction in such a remote location. This presents a whole set of problems, similar to the building of Hoover Dam 70 years earlier.
We knew the site was remote, but the remoteness of the site has truly been a difficulty to overcome with most every aspect of the design and construction of the skywalk.
There's no electricity here. That will have to come from portable generators. There's no water. Every drop will have to be trucked in. And there are no facilities for human subsistence, so temporary arrangements will have to be made to feed and house the work crew. The nearest city, Kingman, Arizona, is 110 kilometers away. And construction vehicles must drive the last 22 kilometers on a difficult, unpaved, and deeply rutted dirt road to access the location. With good organization, Bill Caron and his team are able to overcome these logistical obstacles, but they still face many unforeseen challenges to finally realize the dream of building Skywalk. The Grand Canyon Skywalk offers a unique perspective of one of the most visited places in America. Along with the canyon itself, the sheer force of nature is the star of the show. High winds often rip through the canyon, which helped carve the steep rock walls over past millennia. Since no one has ever studied the wind at this particular location, Locksaw sets up a weather station to gather data and measure the expected wind loads on the structure. They soon learn that velocities up to 145 kilometers per hour are common on any given day. These high winds create unique problems for the engineers and the cantilevered skywalk they are building.
There's nothing in the code that tells an engineer what to do with wind loadings right at the edge of the Grand Canyon. So that was one of the first challenging things that we faced.
Because the skywalk will hang 21 meters over the edge of a 1,200-meter cliff, high winds will hit it from multiple directions, from above, below, and across. This calls for special calculations.
The forces are huge, and we had to apply it in all 3 directions. Usually, when we analyze the wind, in addition to gravity loads, then we applied wind just one direction. I see. How about the perpendicular direction to that one?
The weather station also measures rates of erosion caused by wind, precipitation, temperature, and gravity. These elements can turn a hairline fracture in the rock into a gaping chasm.
And what happens there at the canyon is these rock falls, whether or not it's due to freezing and thawing in the winter or heating in the summer, finally the last grain that's holding the material up breaks up into pieces, and then the block falls. It's a very slow process, but it occurs in sporadic events. You might call this catastrophic events.
This kind of differential erosion accounts for the look of the terraced layers of the canyon walls over the last 1.5 million years. The full story of the Grand Canyon's creation is much more dramatic and is still being debated. Over millions of years, the surface of the land, which is now the Grand Canyon, rose and fell with tectonic activity. At times, the area was flooded, creating a marine environment where debris settled to the floor. This debris was then compacted into layers of sedimentary rock. As the Colorado River formed, it began to cut into the sedimentary rock. It has long been thought that the river carved the canyon's present course between 6 million and 1 million years ago. However, new studies suggest it may have begun as long as 17 million years ago. Given the strength of the bedrock and the need to minimize impact, the engineering team studies various options for Skywalk's foundation.
I got thinking it would be very difficult to attach it to the cliff, so I made the decision to bring it above the cliff and then lock it down to the top of the cliff and place the visitor center on top.
To lock Skywalk down to the top of the cliff, the team decides to build the foundation directly into the rock with caissons and micropiles. The 4 caissons are reinforced concrete columns. Micropiles are an engineered system of threaded steel bars that go inside the caissons, adding strength. Each micropile measures 6.5 centimeters in diameter and extends 14 meters down into the rock. This method of reinforcing a foundation is called post-tensioning. With the plan in place and work about to begin, the Wallapai blessed the construction site on October 1st, 2004. A month later, the tedious work of drilling begins, using diamond-tipped drill bits and compressed air hammers.
Very difficult. Put it this way, I mean, they were breaking tips on the bit like every 5 to 10 minutes, they were breaking a bit. So that tells you how hard this rock was, and the material that we were trying to core through was extremely hard. Some of the hardest material that I've ever encountered.
As drilling proceeds, an unexpected and potentially devastating problem rises. The hole being drilled for one of the micropiles appears to be heading toward an intersection of 2 geologic cracks in the bedrock.
It was fairly evident that the chances of intersecting one of these joints by the drilling operation was fairly high. And as it turned out, they did intercept one of the vertical fractures, and some of the compressed air used in the drilling escaped along the fracture, which indicated that it might be open a little bit.
If the fracture opens too much, the entire project is in jeopardy. The builders might have to start over at a new location.
I thought it prudent to go over the cliff in a cage and take some measurements and to look at the joint system below the top of the cliff.
6 meters below the rim, John Peck finds the open fracture on the rock face. It reaches 4 meters into the canyon wall, just 1 meter from the hole being drilled for the micropile.
That caught everybody's attention.
The team decides to implement a rock bolting system inside the caisson to stabilize and reinforce the fracture. Using a grid of horizontal and vertical steel bars, they literally knit the rock together across its fracture pattern. This alleviates the pressure on the crack. The solution works. The crisis is averted, and drilling continues for the micropiles. Once in place, both the micropiles and the rock bolts are encased in concrete, along with 2 steel columns over each caisson. These will become the attachment points for the Skywalk's structural frame.
So this is the foundation for 2 of the 8 columns for the Skywalk, and basically it's a concrete cap that was poured on top of the micropiles and caissons below. And we also embedded this 2'8" square steel columns in the concrete to actually support the box beam Skywalk itself.
A year and a half after drilling began at the location, Skywalk contractors finished pouring the concrete foundation. David Jin and his family are there to celebrate the moment and mark the spot. The foundation is tested to assess its ability to support the projected load, and it exceeds all expectations, measuring strong enough to support over 32 million kilograms, or the equivalent of 71 fully loaded 747s.
We actually went overboard, I think, in some areas. So we did a lot of extra things according to the geologist's recommendations and the structural engineer's recommendations to make sure that it all went well, because this was never done before, and this type of a construction project was never done before.
For the Wallapai, building Skywalk is an important step to the future. But it's equally important that future visitors respect their past, their customs, and the land they call home.
Wallapai people have lived in this part of the world since the beginning of time. That's our belief.
It was natural, quiet, peaceful. They say the wind tells you things, and if you really listen, it does.
The Wallapai are traditionally nomadic, migrating over lands from the Colorado River southeast to Wickiup, Arizona, and from the current site of the Hoover Dam east to Flagstaff, over 24,000 square kilometers. In the 19th century, the population of the tribe was decimated by war and disease. Their land was occupied by white settlers, forcing the Wallapai to live on a reservation. Established in 1883, it covers just under 4,000 square kilometers, reaching the edge of the South Rim. Since the 1950s, the Wallapai have considered various business interests, with the primary focus on river rafting and West Rim tourism.
We don't have the other industry that other Indian tribes enjoy simply because of their location. But in a way, we're taking advantage of this location, and there's a delicate balance between nature and development for the Wallapai people.
In developing Skywalk, the Wallapai are counting on the delicate balance of a horseshoe-shaped bridge hanging over a huge cliff. And the key to making this happen lies in the beams that support it. Skywalk's major support beams are called box beams. These are giant, curved, hollow steel beams specially designed to handle huge loads of weight and stress. These box beams are 2 meters tall and large enough to walk inside.
These beams are 32 inches wide, 72 inches deep. They're made out of 2-inch thick steel plate, 50,000 psi. So it's a very strong steel plate, very large box beam section. Right here we have one of the cross beams, but this cross beam is to help lock the two beams together.
Another function of the box beam is to absorb vibration and avoid galloping in windy conditions. Galloping is a wind-induced movement on a support beam, which causes amplified oscillations and instability. In a worst-case scenario, galloping can cause catastrophic structural failure, such as the collapse of the Tacoma Narrows Bridge in 1940. The galloping was caused by modest 65-kilometer winds. To prevent any galloping at Skywalk, where winds are significantly higher, the box beams are made with 5-centimeter thick steel plates. Their hollow design is engineered to flex in the wind and absorb vibration. The beams are custom fabricated in Utah in 12-meter sections and then trucked to the Grand Canyon. Shipping the box beams is a big endeavor. It takes months for all the sections to arrive at the location.
Once they were here, it's a matter of just turning the crew loose and going to work and putting them together.
For safety, the skywalk is assembled over land. It will be rolled out over the cliff later. First, permanent caps are attached to the 8 concrete columns. These will help anchor the skywalk. Next, the crew builds a network of temporary sawhorses to support the box beams as they are positioned for welding. Finally, the box beams are lowered into position using a large construction crane.
It really took a lot of precision in layout to put all the parts and pieces together. A curved structure that's 2 inches thick is not an easy thing to put together within 1/8 of an inch of accuracy.
After the sections are precisely aligned, welding begins on the 500,000 kilogram structure.
It took quite a bit of welding, quite a bit of visual and x-ray inspections of the welds themselves to make sure that they adhered. A lot of time, a lot of months in welding that entire structure together.
It takes a month to weld the horseshoe-shaped frame together. With the structure complete, the reality of a cantilevered bridge jutting out over a 1,200-meter drop weighs heavily with Bill Karen.
One of the things I've thought about all through this project is I want people as they walk the bridge to feel safe and comfortable despite the fact they're walking on glass and looking thousands of feet down the face of a cliff.
The combination of wind and the weight of random foot traffic on the skywalk will cause vibrations on the structure, potentially frightening to visitors. This problem has to be solved. The answer is an engineering device called a tuned mass damper. Like shock absorbers, tuned mass dampers counteract vibrations by applying equal pressure and force in the opposite direction. Here, a weight mounted on springs counteracts wind and weight vibration, stabilizing the structure and dissipating energy as heat generated by the friction of the movement. 3 TNDs, each weighing 1.6 tons, are specifically calibrated to meet the wind and weight requirements of the location. They are placed inside the horseshoe-shaped steel frame, 2 inside the beam of the outer arc and 1 inside the beam of the inner arc. With these installed, the skywalk frame is now structurally sound, but still no one knows how it will behave over the edge of the cliff. That test is still to come. Ten years after the idea was first proposed, the horseshoe-shaped frame of the Grand Canyon Skywalk is finished and ready for the next step. Now it's time to add the defining element: Skywalk's unique glass floor. Engineers choose a glass made up of 5 layers, a total of 8 centimeters thick. The layers are bonded together and laminated with a special interlayer adhesive to strengthen exposed edges and enhance clarity.
If they selected a glass and an interlayer product, it would give a very clear view.
Each pane measures about 1.2 meters wide and 3 meters long, and weighs about 545 kilograms. While the steel frame of the skywalk supports its own weight and that of the glass, each pane of glass supports a live load of 488 kilograms per square meter, or about 800 people. This far exceeds the 120 visitors allowed on the skywalk at any given moment. To account for gravity and wind loads, The composite glass is measured to support downward forces of 488 kilograms per square meter. Additional strength tests project that the glass can sustain upward wind forces of 390 kilograms per square meter. Similarly, the thinner glass on the curved railings withstands 390 kilograms per square meter from any direction. Skywalk's glass walls were originally designed to be 2.1 meters high, but engineer Bill Karen fears that will feel too confining for visitors. So he proposes a height of 1.6 meters.
Now the code only requires it to be 42 inches tall, so we decided on 5'2", so we were a little bit safer than the code, but you don't feel confined when you walk the skywalk. It's very open.
Visitors are required to wear cloth booties, but even so, small scratches and scuffing of the glass is inevitable. Fortunately, the 5-layer composite allows for periodic replacement of just the top layer, lowering maintenance costs to a fraction of full replacement. The machine used to move the large glass panes during the original installation and for replacement is called a manipulator. Powered suction cups on a crane-like arm pick up the glass. The glass is then tilted 90 degrees for one last cleaning. The operator then gently lowers the pieces into place. Although the glass is very strong, it is also very heavy and can break under its own weight if it falls or collides with rock or steel. The sheer weight of each pane presents a problem as the engineering team prepares to install the glass walkway. Because the box beams bend slightly under weight loads, the team worries that as each pane is placed, it will cause the steel to bend and possibly break a pane that's already been installed. Any miscalculation can result in a shattered piece of glass. To counterbalance the frame during installation, workers set out a layer of temporary steel plates to simulate the weight and size of the glass panes.
So we actually emulated the weight of the glass as if it was on there. So we went around and put steel plate on each section as if it was a piece of glass. So as we put a piece of glass on, we take a piece of plate off to make sure we had the right balance of weight. So it basically had that same bend, if you will, with all the glass on it at the end of the day.
And there's one final consideration in securing the sheets of glass. Spaced roughly 3 meters apart, the inner and outer box beams of the skywalk move independently of each other. Over the course of a day, the heat of the sun and the weight of pedestrian traffic can cause the box beams to move, slightly shifting the glass panes up or down, creating an uneven surface. To solve this, small bearings are installed to compensate for these height variations and provide a level foundation and cushion for the glass. With the glass in place, it's now time for the big moment, to roll the giant frame out over the rim of the canyon.
We were very, very nervous, very anxious. It was very, very intense to make sure everybody was on the same page on what we wanted to accomplish.
The rollout crew has been preparing for this moment for months. First, they raised the frame off the temporary sawhorses used during welding. Next, they lower the frame onto the rolling jacks that will carry the payload to its ultimate location.
We use the old Egyptian rod plate method where you move one plate, you move the rod to the next position, you roll it a little bit and you move it again.
The Egyptians used this rod and plate method to move heavy objects, like the blocks used to build the pyramids. At Skywalk, each section of the box beam frame is jacked onto a platform with a roll of rods underneath. The rollers minimize friction, so a relatively small force is needed to roll the structure in a straight line. 2 winch trucks are used to move the Skywalk. pulling cables are attached to a temporary cross brace on the structure, fed through pulleys attached to the foundation columns, then run back to the trucks. As the winches reel in the cables, the skywalk inches forward over the canyon's edge.
We were going to move 1,571,000 pounds over the edge of the Grand Canyon without having to go over the canyon.
It's not just the weight of the skywalk they have to move. Because the engineers worry that the frame might tip over the edge, they pile 250,000 kilograms of steel plates on the back of the frame to counterbalance the weight. The team also worries about a runaway once the rolling begins.
Pretty hard to stop 1.5 million pounds once it gets going.
So they borrow another trick from ancient Egypt.
We basically would throw sand in front of the rod, and actually what that created was a friction between the rod and the plate, and it actually stopped the skywalk.
2.5 years after the groundbreaking ceremony, the skywalk team is ready. The rollout begins. Centimeter by centimeter, the crew carefully rolls the skywalk toward its ultimate position, 21 meters away. They get halfway there after a full day.
We had to roll it out without breaking any of it. So move it out approximately 70 feet at 1.5 million pounds without breaking any pieces of glass, and that was a feat in and of itself.
On the second day of rollout, the methodical effort pays off. Skywalk reaches its final position. Now they have to secure it. The jacks gently lower the skywalk on its foundation. As soon as the box beams are fitted over the 8 columns, welding urgently begins.
We then immediately started preheating the steel and running the beads, the weld beads. Well, each section, each side has 128 runs on top and on bottom, all the way around all 4 sides on all 8 columns.
The welders don't stop until the job is done. Then the entire crew breathes a huge sigh of relief. The Grand Canyon Skywalk is secure and ready to be unveiled. After 2.5 years of construction and $30 million, the horseshoe portion of the Grand Canyon Skywalk is complete in March of 2007. Over 500,000 kilograms of steel and glass extending 21 meters over the canyon rim, suspended over 1,200 meters of pure air. An engineering marvel showcasing a natural wonder. After extensive testing with X-rays and ultrasound ensures that the structure is firmly tied to its foundation, it's time for the opening ceremonies. It's the moment of truth for everyone who has risked making Skywalk a reality. They begin on a chilly morning with a blessing from the Wallapai spiritual leader.
All the tribal people came out. They were allowed to go on the skywalk, and the man that had the idea to put the skywalk here, David Jin and his family, and all the tribal members were here, and it was just very spectacular to have all those people together.
For the next 2 days, David Jin and the tribe welcomed the media and special guests, including astronauts Buzz Aldrin, the second man to walk on the moon, and John Harrington, the first Native American to fly in space.
This magnificent first walk bridges centuries of vision towards the future of hope.
The first step out on the skywalk, you really didn't know what you were going to experience. You couldn't see down the bottom right away. And then when you got on it, you looked down, and to see way down there sent chills and thrills down your spine.
You're actually walking on air when you walk out onto the glass floor and you look down and you basically see an endless sea of rock and beauty in the Grand Canyon.
When the gates open to the first customers, excitement mounts even more.
The one thing I would say was that if you were anywhere near this area, it would be a big mistake not to come here. It was definitely worthwhile. Definitely worthwhile.
And I thought I would be nervous or anxious or feel queasy. Not at all.
Visitors give their approval, but there is one cause for concern. A layer of cushioning foam between the glass and the steel beams provides an unexpected sensation on opening day.
When you first walked it, you could hear a little crunching sound. So it was kind of crunch, crunch. But as thousands of people have walked it, the crunching has gone away, thankfully.
Worry about crunching glass may be history, but the fear and butterflies of first-time visitors remains all too visible.
A lot of times, first-timers will do something like this. They'll tap the glass with their foot, gain a little confidence and step, carefully bring out their second foot. Then they'll test it out a little bit like this.
See, we're okay. Just one step at a time. See, that's how you do this.
Now, some people are frightened to walk right down the center, so they'll actually scoot over to the side, and you can see right above the bridge beam. You can't look down. You can put a death grip on the handrail and then kind of work your way down the skywalk.
Can I go through there? I know. I'm just gonna stay here. Look at that.
No.
Awesome.
I'd read about it, but you don't ever know until you're actually on it how you're going to experience, what you'll experience.
Picturesque. It's absolutely beautiful.
As the skywalk draws visitors, the Wallapai continue developing additional areas of Grand Canyon West for tourist uses. Near the skywalk, a display features the traditional dwellings of several different tribes, including Navajo, Hopi, and the Havasupai. For Wilfred Watanabe Sr., the skywalk is just one piece of a greater source of pride and economic growth for the Wallapai.
Because this is trying to expose to the public that there are other Indian tribes. They do have different traditions. They do have different types of dancing.
And for his son, Wilfred Watanabe Jr., the skywalk is a symbol whose meaning is not yet certain.
For future generations, I hope we made the right decision. What we do here is we actually lay the groundwork, not for us, but for our children and our grandchildren. We maintain that balance between the natural and spiritual beauty. And if we do that, then I think we'll be fine.
Both agree they need to balance heritage and development to preserve and enhance wealth of spirit and economic growth for generations to come.
We look westward, we see this beautiful area as it was in the past. And, it's such a beautiful area from this vantage point here. And we turn around and we look eastward, we see the future, with development.
Grand Canyon West is actually a sacred site. We have tribal members that dance over here at the Skywalk with the younger children, maybe 9 or 8 years old.
The Skywalk represents, I would say, a brighter future for the future generations.
Soon, a visitor center and restaurant will be added to the complex, resting on top of Skywalk's foundation, completing the vision of a unique tourist experience at the edge of the Grand Canyon.
The idea was just for folks to come enjoy the beauty of it all and have a bird's eye view, if you will.
Yeah, it's really far down.
It's a one-of-a-kind type of a structure that really gives you the beauty and the opportunity to look at the beauty of the Grand Canyon.
The Grand Canyon is spectacular. That's been one of the greatest things I've had to deal with this project.
Tourists from around the world visit the Skywalk every day. And that first step is thrilling.
And I'm afraid of heights, so this I have really been. I'm not, but this is really scary.
It was a unique experience of the life.
To walk in the sky, it is something we feel we are on the top of the world.
Namaste.
Namaste. Yes. Yes.
It makes me very nervous to look down. It's like a bird, and I feel like I was falling.
It's a little dizzy for me, at least. You know.
It's gorgeous.
But it's beautiful.
It's gorgeous.
The Grand Canyon Skywalk, a living monument to showcase human imagination, natural beauty, and true engineering ingenuity. A visionary structure in a grand location where people can now fly with the eagles.